Hello and welcome to the Unit 4 Section 10 video on slope-intercept form and point-slope form. So in the last section we talked a little bit about slope-intercept form. How do you write the equation of a line if you're given the slope and you're given the y-intercept? How do you find those things on a graph and write your equation of the graph? Well, now in this section you're going to be given additional information. You'll be given either a point and the slope, or you'll be given 2 points. And you're going to have to figure out, how do I still get my slope-intercept form of my equation of the line? So just as a reminder, we talked about slope-intercept form in the last section. It is y equals mx plus b. So the slope is fairly straightforward. You're either going to have to find or calculate the slope and substitute it in for m in the equation. So if you're given the point and the slope, well, you're given the slope and you're good. But if you're given 2 points, then you're going to have to find the slope by using the slope formula. And as a reminder, the slope formula is m equals y2 minus y1 over x2 minus x1. Now, what if you're given 2 points? Well, that's how you find the slope. But you notice we have no intercept given to us. We don't know what the y-intercept is unless one of the 2 points happens to be the y-intercept. So we use 1 point, and we're going to label the x1 and the y1, and then plug it into your slope equation. Now, we are going to be solving for y when everything's said and done, and then rewrite it in slope-intercept form. But here is the deal. This is going to be a little unwieldy to work with. So let's get another form, and this is called point-slope form. And this is what you're going to plug into when you have a point and the slope. And point-slope form is y2, or I should just say y minus y1 is equal to m times x minus x1. All right, so what you're going to do is take 1 point, you'll label the x1 and y1, and you're going to plug that in for x1 and y1 here. You'll take your slope and plug that in here. Then it's going to be a matter of distributing and then moving this value to the other side. And you're going to see how that works in the examples here. So let's start with the simpler of the two situations. And that is if you're given a point and the slope. So for this, we're just going to go straight with point-slope form. Y minus y1 equals m times x minus x1. y1, in this case, is going to be negative 2. This is our x1, y1 right here. This is our slope. So y1 is negative 2. Our slope is negative 1/5, and our x1 is 5. So I'm going to do a couple of things at one time. On this side, I'm going to go ahead and do minus our negative, which is y plus 2, and then I'm going to distribute on the other side. I have negative 1/5 x. Negative 1/5 times negative 5 gives me positive 1. And then I'm going to subtract 2 from each side. And then that's going to give me y equals negative 1/5. Let me write that a little bit better. Y equals negative 1/5 x. 1 minus 2 gives me minus 1. All right, for the second one, again, this is my x1 and my y1. And this is my slope. So I'm just going to plug in to my point-slope form. So that's going to give me y. I'm going to kind of shortcut these a little bit. Y minus negative 2 gives me y plus 2. Actually, I'll keep that step in here. We have y minus negative 2 equals our slope, negative 5/3, x minus x1, which is 2. All right, so this, as we said, is y plus 2. If we distribute, we get negative 3/5 x plus, because we have minus times a minus, 2 times 5 is 10, so we have 10/3. Well, 2 is the same as saying 6/3, right? 2 equals 6/3 to get our common denominator. So I am going to subtract 2 from each side, which in this case is subtracting 6/3. And so you're left with y equals negative 5/3 x plus 10 minus 6 is 4/3. For number 3, we have our point 5, negative 4. So we're going to plug into our point slope form. So we have y minus negative 4 equals negative 2/5 times x minus 5. All we did was plug in. And now we solve for y. We clean up the left side. We distribute the right side. Negative 2/5 times negative 5 is going to give me positive 2. And then we're going to subtract 4 from each side. And so we get y equals negative 2/5 x minus 2. For number 4, we have our point, negative 4, 0, and our slope of 0. So this one, let's put it into point slope form and see what we get. Y minus y1 equals m times x minus x1. Well, y1 is 0. Our slope is 0. And we don't even have to distribute this, because 0 times anything is going to give us 0. Y minus 0 is just y. And on this side we have 0. So our equation of our line is just y equals 0. We have a horizontal line that's along the x-axis. All right, number 5. Here we have y minus y1 equals m times x minus x1. So here our y1 is negative 1. Our slope is negative 2. And our x is 2. So we have y plus 1 equals negative 2x. Negative 2 times negative 2 gives me plus 4. Subtract 1 from each side, and you have y equals negative 2x plus 3. Now, what if we have a slope that's undefined? Well, we're not necessarily going to use our slope equation, our point slope form, or our slope intercept form. We're going to use what we know about slope that's undefined. If slope is undefined, we know that our line is going to be vertical. So if our line is vertical, that means we're going to have x equals something. And all you have to do is look to your point that it goes through to see what x equals. And x equals 2. And it's because of this x right here. Okay, so that's fairly straightforward enough if we have a point and the slope. What if we don't have the slope? Then we're going to have to figure out what the slope is by using m equals y2 minus y1 over x2 minus x1. So here, we'll just call this x1, y1, and this x2, y2. So now we're just going to plug in. y2 is going to be negative 1. y1 is going to be 5. x2 is going to be 0. x1 is going to be negative 2. And so we've got negative 6 over positive 2, so our slope is negative 3. So now we can take our slope and whichever point we want to use. I tend to go with the one that looks like it's going to be easier math-wise. So for this one, this has a 0. I'm going to use this one because a 0 is really easy to work with, because whenever you multiply anything by 0, it just goes away. And so now we're going to go back to our point slope form, and now we have a problem that's just like what we did on the previous page. Here y1 is negative 1, our slope is negative 3, and our x1 is 0. So you have y plus 1 equals negative 3x. Negative 3 times 0 is 0, so there's no need to write that. Subtract 1 on each side, and you're left with the equation y equals negative 3x minus 1. For number 8, we have our y2, which is 3, y1, which is 2, x2, which is 0, and x1, which is negative 5. So here we have 1 over 5 as our slope. Then we go into our point slope form to find the equation of the line. All right, so now we have y minus, let's use the second point here. So we're going to go with 0, 3 as the point that we use for the same reason, because 0 is easy to work with. So our y1 is 3, our slope is 1/5, our x1 is 0. So we have y minus 3 equals 1/5 x. Add 3 to each side, and that's going to give you y equals 1/5 x plus 3. All right, for number 9, I'm going to show you that it doesn't really matter if you do this is y1, y2, or x1, x2, and this is x1, y1. Okay, it doesn't really matter as long as you stay consistent. So I'm going to make this x2, y2, and this x1, y1, because it doesn't really matter as long as you just label one with 1s and the other with 2s. So, and sometimes I feel like it's easier to do it this way, because then we just do our y's, 5 minus 2, and you're kind of reading it from left to right, over negative 2 minus negative 5. So on the top we're going to have 3, on the bottom we're going to have negative 2 plus 5, which is going to give us 3, and so we have a slope of 1. So now we're going to plug in y minus y1 equals m times x minus x1. And here it's kind of a draw. Let's go ahead and use, you know what, let's use the second point and see what we get. We'll use the first one. It doesn't really matter which one you use. You'll still get to the same thing. So we have y minus 5 equals m times x minus negative 2. Well, that is going to give us m times x plus 2. We go ahead and distribute, or you know what I didn't do is I did not plug in what m is. In this case, m is 1. Well, what is 1? 1 is just going to give us what's on the inside of here. So we're just going to have x plus 2 here, and then we add 5 to each side, and you're going to get y equals x plus 7. All right, for number 10, let's do our y's, the difference of our y's over the difference of our x's. So that gives us negative 6 over negative 1, which is going to give us positive 6. Let's use the first point since it has a 0 in it, and we'll go to work. Y minus y1 equals m times x minus x1. y1 is going to be negative 1. Our slope is 6. Our x1 is 0. And so you've got y plus 1 equals 6x, because 6 times 0 is 0. No need to write anything here. And we subtract 1 from each side, and you're going to get y equals 6x minus 1. All right, 2 more examples. For number 11, we have our slope being our difference in our y's, so 1 minus 5, over the difference of our x's, 2 minus 0. So that's going to give us negative 4 over 2. And negative 4 over 2 is going to give us negative 2 for our slope. And let's use the second point since it has a 0 in it. So y minus y1 equals m times x minus x1. So y1 is going to be 5. Slope is negative 2. x1 is 0. So we have y minus 5 equals negative 2x. And if we add 5 to each side, that's going to give us y equals negative 2x plus 5. And then finally, for the last problem, the difference in our y's, so 3 minus 1, over the difference in our x's, negative 4 minus 0. That's going to give us 2 over negative 4, which is negative 1/2. So our slope here is negative 1/2. And we're going to use the point 0, 1. So we have y minus y1 equals m times x minus x1. y1 is going to be 1. So we have y minus 1 equals negative 1/2 x minus 0. So that gives us y minus 1 equals negative 1/2 x. And then if we add 1 to each side, our final answer is y equals negative 1/2 x plus 1. All right, so that's a little bit of how to use a point in the slope, or if you have 2 points, how do you get to your equation of your line in slope-intercept form? And that is by using point-slope form to get there and then solving for y. All right, next section we are going to talk about standard form and how we write equations in standard form and what that looks like.